All right, so this is lesson 6-4, number 1. And here's the problem. The average admission charge for a movie is $5.39. So the first thing you want to do is draw your normal curve. We're assuming the data is normally distributed. And put your average at 539. So X bar is 5.39. And actually, for the mean, we're going to use population mean of mu instead of X bar in this case. All right, next. If the distribution of admission charges is normal with a standard deviation of 0.79, what is the probability that randomly selected admission charge is less than $3? So our standard deviation is 0.79, 79 cents. They want to know what's the probability that an admission charge at a movie would be less than $3. So would I put the $3 to the right of 539 or to the left? To the left. Yeah, it's less. This is a number line. This is our x axis. So $3 is going to be down here somewhere. That's our x value. So what we want to do is we want to transform this normal distribution into a standard normal distribution. Now a standard normal distribution doesn't use x on the horizontal axis, it uses z. And z-scores, remember, are the number of standard deviations from the mean. So if you're at the mean here in the middle, your z-score is 0. $3 is out here somewhere. Okay? We need to transform that x-coordinate into a z-coordinate. We do that with this formula, the formula for z-score. You take your real-world data value, x, minus your mean, which is $5.39, divided by your standard deviation, which is 79 cents. It's going to look something like this. Z equals $3 minus 5.39 divided by the standard deviation, which is 79 cents. You can type that in your calculator, figure out what that comes out to. I'll do that quick. Or if someone has the answer, you can tell me. 3 minus 5.39. Make sure you get that answer first before you divide by 0.79. Or if you're going to type it in all at once, you're going to want to make sure that you put parentheses here. You want to make sure this subtraction happens before the division. So I can go parenthesis 3 minus 5.39, parenthesis divided by 0.79. So I'm at negative, z-scores we're going to round to 2 decimal places. So negative 3.03. My z-score. So $3 is a little more than 3 standard deviations below the mean. Now this probably isn't drawn to scale because we know that 99.7% of the data falls within 3 standard deviations of the mean, so it's probably actually out here further to get a more accurate picture, but I'm not too concerned about that being perfectly accurate. So now what we're trying to find is the area to the right or to the left of that z-score? To the left. Yeah, because it said less than $3. Less than $3 would be to the left of $3. So I'm trying to find this area. So you go to the z-chart, you look up 3.03. So you go down here to 3.0, you go over here to 0.03, you look in your z-chart. Now, is that value shown in your z-chart? Yeah. Find my z-chart here. On your z-table, your z-score table, yep, you go way to the bottom, 3.0, you go over to 0.03, what number do you see? 0.4988, correct. So 0.4988. Now remember, that value is always the area to the right of the mean. So that value, 0.4988, is actually this number right there. And you can remember that because on your z-chart, it shows you that little shaded area down there. But we know this is a symmetric graph. The right and left sides are mirror images of each other, so this area would also be 4988. So what can I do to get that area?
0.5 minus.
Right, 0.5 minus that number. So 0.5000 minus 0.4988 comes out to 0.0012. 0.0012 is that area. So the probability that if you were to go buy a movie ticket, make sure I'm saying that right. Right, if you go to a movie, whenever this textbook was written, and this comes from the New York Times Almanac, at that point in time, the probability of going to a movie and paying less than $3, 0.0012 or 12 out of a 10,000 chance. Pretty unlikely that's going to happen. Okay? So you're finding final answer, your probability is 0.0012. Any questions about that? I'm gonna stop this and start it again, do number 2 then.